Hello everyone. So today the problem that we are going to solve is of the weekly contest, that is zero array transformation 1. So we are given an integer array nums of length n and a 2D integer array queries where queries at I is of type li and ri. For each query, we need to select a subset of indices within the specified range in the query, decrement the values in the selected indices by 1, and a zero array is an array where all the elements are equal to 0. We need to return true if it is possible to transform nums into a zero array after processing all the queries sequentially. Otherwise, we need to return false. A subset is an array. A subset of an array is a selection of elements, possibly none of the array. Okay. So let's consider this test case. We are given this array and we are also given this queries that we have to perform. And the first query is of this type, let's say 0 to 2. So what this means is that we need to select some elements from the index 0 to 2, which is this is 0, then that is 1, this is 2. So we need to select some indexes and perform the operation, that is decrement the values at the selected indices by 1. So in this question, as we have also said, that we can select the indices I is equal to 0 and I is equal to 2, which are both in the specified range, and we can decrease those values by 2, and once we do that, the array will become 0, which is also a 0 array. So in this case, it is possible to do that. Whereas in this case, if we try to do that, and let's say I select all the indices in the given range, that is 1, 2, 3, that is this subarray, and I decrease all the values in this subarray by 1. So still the array will become this is this. And then I again perform this query, but still these two values will remain as non-zero, and thus the array will not become a zero array. So that is basically the problem that we have to solve. And one possible way of doing is using the brute force approach. So what we will do in that is we will select the entire range specified by a query and decrease all the values that are non-zero. I will repeat, for each query given in the queries, we will select the segment specified by the query and decrease all the non-zero values in the segment by 1. And if after processing all the queries, the entire array contains only zeros, then we will return true, otherwise we will return false. So let me quickly implement this. So I'm going to take an integer n to denote the length of the array, and I'm going to run a loop through all the queries. So I'm going to say for each query in queries, and I know the starting point of each query is given by the first element and the ending is given by the second element. So I'm going to keep that into variables, and then I just need to run a loop in this segment, which I can do by saying for int I is equal to start while I is less than equal to end and I plus plus. And what I need to do in here is to select all the non-zero elements. So I'm going to say if num set I is 0, I'm not going to do anything to that, so I'm just going to continue from here. Otherwise I will decrease that value by 1. So what we are doing here basically is, by this for loop, we are selecting each query that is present in the queries array one by one, and for each query I store the starting of the range denoted by that query and the ending of the range denoted by that query, and I run a loop in that range and decrease all the non-zero values by 1, which is also what I just said while explaining what we will be doing. So now let me just run a loop to check whether all the elements in the given array have become 0 or not. So I can just do that by running a for loop, and I'm going to say here, if any element in the given array is not 0, that means you were not able to make a 0 array, in that case I will return false. Otherwise, if all the elements are 0 and the loop completes entirely, then I can return true, because then that means that all the elements have become 0. So I can run this, and it works for the sample test cases. So let me just submit it. So as we can see, it passes most of the test cases, but we get time limit exceeded for some test cases. And that is because the approach that we have implemented here, if we have, let's say, q queries, and each query can be at a maximum from 0 till n minus 1, that is the entire array, that is each query is targeting the entire array, and the total time complexity of this would be q times n, where q can go up to 10 raised to the power 5 and n can go also up to 10 raised to the power 5, which is not something we can do within the time constraints. So we need to optimize this somehow. Now, there can be several ways to optimize this, and I'm going to discuss one of them, which is a very useful approach of difference arrays. So, in order to explain what a difference array is, let me consider an array which is of this type 1, 2, 4, 5, and 6. It is not related with the question. I'm trying to explain what a difference array is. So, let's say we are given this array and we want to create a difference array for this array. So, what the difference array's entries store is how the element has changed as compared to its prior element. I'll repeat that again. So each entry in a difference array indicates how much the current element in the given array has changed as compared to the prior element. So for the first element, we do not have any prior element. So the change is equal to the given element itself. So for the first element, it will be 1 itself. And for the second element, we can see that we have a 2. And the previous element to that in the given array, that is nums, was 1. So it has increased by 1. So we store that. That is a plus 1. That is, the previous element has increased by 1 to reach this current element. Now the next element is a 4. So it has increased by 2 compared to its prior element. 5 has increased by 1 and 6 has increased by 1. Okay. So we know this about the given array, that this is the difference array corresponding to this array. I will also add one more entry to show how the values decrease. Let's say the last element is 1 and I can say that the element has decreased by 5. The last entry will be minus 5. Okay. Okay, so this is the given difference array for this array. And let me just call this array as AR. Okay, so now how can we use this difference array in our question? So one useful operation that we can do very quickly using difference array is the update operation. That is, we need to change the values over a segment by a given amount. I will write that down. We need to change the values over a given segment by a given amount. So what do I mean by that? So let me consider an example here. Let's say in the given array AR itself, somebody asked me to increase the values from 1 to 4 by 3. So what this means is that the desired result after performing this operation would be the first index, that is 0, remains same. The value at index 1, that is 2, will increase by 3. So will the value at index 2, and so will the value at index 3 and 4, and the other value will remain same. So this is the desired result after performing the operation. So what if we just now try to create the difference array for this, you will see that the first element is 1, the next element has changed by 4, then it is a 2, then it is a 1, then it is again a 1, and the last element has decreased by 8. Okay, so this is the difference array for this array now. So if I try to compare this difference array with the older difference array that we had, we can see that the first element is same, the second element has changed, the next three elements are exactly the same, and the last element has changed. And if you try to see, the elements that have changed are actually the beginning of this range, that is the first index, and the element at index last index plus 1, that is the fifth index. So what this means is that once an operation is performed, The difference array updates only need to be done at the starting of the range and at the ending of the range plus 1. Now, why does this happen? It's because the difference array stores how much the element has changed as compared to its previous element. And whenever we perform an operation over a range, the elements that are in the middle of the range, that is, not the first element, but all the rest of the elements are going to differ from the previous element by the same amount as they used to differ earlier, because we are adding a constant value to all of them. Let me just try to explain it with a general case. So let's say my elements were A1, A2, A3, A4 and A5, and somebody asked me to increase the elements from 1 to 3 by x. Not increase exactly, but just change. So now the elements would be A1, A2 plus x, A3 plus x, A4 plus x, and A5. So if you see that this entire range, all the elements have increased by the same amount. And if you try to compute the differences between these elements, that is this element and this element, the difference will be A3 minus A2. Similarly for this and this, the difference will be A4 minus A3. The only differences that will change will be between this and this, because this element A1 has not changed, but A2 has changed. And the next change would be between A5 and this element, because this element has changed and this element has not changed. So if we try to compute what these changes will be, we can see that the first element, that is this A2 plus x minus A1, and it will give me A2 minus A1 plus x. And if we try to see the earlier difference between these two elements, it was A2 minus A1. So if I call this earlier difference as prev or previous, I can rewrite this difference as previous plus x. That is, we need to increase this difference by exactly x, that is the amount of value that we have changed. Similarly, for the last element, the difference now would be A5 minus A4 minus x, and the earlier difference was A5 minus A4, which I can just call it something like A. So now this can be rewritten as A minus x. That is, we need to decrease the difference stored at this position by x. That is why these values have changed only by that much. So you can try running some examples as well if you don't understand it by this. But this essentially tells us that we can easily perform a query where we just need to update, or change all the values by the same amount over a given range in constant time. So one more thing that I would like to say is that we do not actually need to construct this difference array from the array itself if we just want to perform the operations. If someone actually asks me to create a difference array for array, then this would be the approach, that is to create the difference array using the values in the array. But if I'm only asked to perform some operations, that is just like in this question, I'm asked to perform some n number of operations on the array and then tell the final result, what I can do is I can store what will be the changes only corresponding to the queries that are given. That is, I will not store how the array had. That is, I will not store what the array was initially, how the changes were present in the given array initially. I will just store the changes that are a result of the given queries. So what I mean is that initially I'm going to keep my difference array as all zeros. And whenever someone asks me to perform a query, I will just go into my difference array and I will select the starting position of his query. Let's call it as L, and I'm going to increase it by the given amount, let's say x. And then what I'm going to do is, as we saw here, that is the point just after the query has ended, that is r plus 1, I'm going to decrease by the same amount. And once I do this, I will know what changes have accumulated over time after performing all the queries. And once I have the final difference array, I can run a loop over the difference array, and I can keep a count of how much the current element has changed using all the operations that have occurred previously. This will be more clear once I have created a difference array. So let me just quickly take an example and do this. So I'm gonna take this second example itself, that is 4, 3, 2, 1 is the initial array, and it's performed the queries. So the first query would be from 1 to 3. So a difference array would be initially as zeros, and after performing the first query, what I will do is I will increase the value at first index by 1 and decrease the value at last index plus 1, which is 3. So as we can see, 3 plus 1, the index is 4, which does not exist in the given array. So in order to take into account that fact, I'm just going to add one more element in our difference array so that we do not get an index out of bound error when trying to perform the update operations. And we'll just perform that. I will decrease this value by the same amount, that is 1. Similarly, the next operation is over 0 and 2. So the element at 0th index will increase by 1, and we will decrease the value at 2 plus 1, that is the third index, by 1. So we have got this difference array now. So now the first value of the difference array was 1. That is, the first element has changed by 1. So the first element was 4, it will have changed by 1. In this case, this change means that the value has decreased by that amount. But let us consider that we are just adding the values. That is, let me just write this down. Each query is increase the value from L to R by 1. So we are performing these type of queries, okay? So the first element, as the difference array says, has increased by 1. The 4 would have increased by 1, so we got a 5 here. Now, if we just look at this difference array as it is, it says that the second element has increased by 1. No, it does not say that. It says that the second element is at a difference of 1 from its prior element. I will repeat, it says that the second element is at a difference of 1 from its prior element. So that means that whatever changes have happened to the prior element must also happen to this element. So what we can do is we can keep an cumulative sum coming from the initial position, that is the 0th index, and up to the current index. So that means that we need to take into account this change as well and this change as well. That is, this value will have increased by 2, would have become 5. This value, since the current value of the cumulative change that we have accumulated is 2, this would also have changed by 2. Now we need to decrease that cumulative value by 1. So this will be just changed by 1, and now the change is of 0. And also we do not have any element here. So I'm just going to keep that as it. Okay, it's just changed by 1. Yeah, this would have been a 1. Okay. I meant 2, yes. So this is the final array that we will get after using this difference array for computing the changes over the ranges. If this is not clear, try to take an example by yourself, and if you have any questions or queries regarding the same, just ask me in the comment section. I will try to reply to as many of them as I can. Now, all this is fine. If we try to implement this, we are going to be needing a difference array as we used in the example that I just did, and the size of the difference array will be n plus 1 to take into account the last element, so index bound error that we just discussed. And I'm going to perform each query, so I'm going to select each query in our queries, and I'm just going to do what I just said, that is, I will just increase the value pointed by the start of this query by 1, which is also just plus plus, and I will decrease the value present at the last index plus 1 by 1, and this will build the difference array. Similarly, now to obtain the final array, I will just loop through the entire array. I will keep a cumulative sum as well, just as said, and I will call it C, which will initially 0. I will loop over the entire array. I will take into account the current changes in the difference array by adding it into my cumulative difference. And now I know that the current value has changed by C. What I'm saying, I will repeat, the current value has changed by C, and although in this example I considered that they have changed by 1, but according to the operation described here, we are decreasing these values by 1. So it is not 1, it is exactly -1. So just to take into account, what I will do is I will set nums at I minus equals C. Nums at I minus equals C. That is, I am decreasing the current value, whatever is pointed at I, by C. Now it can happen that, let's say in this case only, the first element would have increased by 1, that is the change would have been of 1, and the same change would also be applied to this. So this would become a negative. But we do not have to worry about that because we have been given the option to select only a subset. So if that would have been the case, we would have omitted selecting this element. So even if this value becomes negative, it is not a problem for us. But if the value remains positive, even after applying all these operations, then we have an issue. And what would be the condition for that? If even after applying the operations that have happened up till now, the value is positive. So this means that this element will be non-zero even after performing all the operations. So we can return false because we need to return whether all the elements will be 0 or not. So if I run this, there we got an error that n is not defined. So I will quickly create the variable n and let us run it again, and it works. So let us submit it, and it works. So we have solved this problem. If you have any doubts regarding how I solved this problem, kindly ask them in the comment section. And if you liked this video, make sure to hit that like button and also subscribe if you have not already. Thank you.